There are 5 questions in the Chapter 7 assignment, but each of the questions are kind of long, so I'm gonna make 5 different videos for you. And in each of these, I'm just downloading the data file that's provided to you in the actual question. And always remember that I'm going to have different values in my questions, so don't just copy the answers that I get. Only follow my instruction, and always make sure that you're paying attention to how many decimal points that the question is asking you to report. And so I downloaded this data, and it's telling us we're looking at the correlation between, or the relationship between students who their test score in correlation to how many hours they spent studying. We can hypothesize that the more hours you spend studying, the higher your test score will be. But we're going to test this, and we're going to test this using a regression, a simple linear regression. And the first thing it wants us to do is to tell us which scatter chart below is representative of the data when our studying is the independent variable. So the only way to know that would be for us to go ahead and run a scatter plot. So I'm going to insert, I can make this bigger for you. Okay, so I'm going to insert a scatter plot. And here's my plot. And of course I can do things like remove the grid lines, give it an axis title. And so my independent variable is our studying, right? Which means it's going to go on my bottom axis, hours, and then this is going to be the grade over here. So when I look at my scatter plot, trying to make it all fit on one screen, I can move this. So it looks to me like, boy, I'm just kind of struggling with this today, aren't I? Sorry about that. Give you a second to take a break here while I figure this out. Okay. When I'm looking at this, grade in hours. As hours increases, so too does grade. So I'm going to look on here and see. This one kind of dips down and picks back up. That one, well, that's bizarre. This one goes down. So I'm going to say that my data is the same as graph 3. And I'm asked, what kind of a relationship does my scatter chart indicate? And it indicates a positive relationship because it's increasing. So with every hour increased, so too does the grade. Then it wants us to develop an estimated regression equation. And to do that in Excel, I am going to right click on any of my values here, added trend line. It's going to be linear. And I'm going to ask it to display the equation on the chart. And it's going to be teeny tiny, okay? But here it is. I'm going to move it out of my dots so we can see it. Maybe I can increase, see, it's a 9. Let's make it a 12. Okay. So that is my linear regression, which says hi-hat equals, well, my hi-hat, my y, I'm sorry, is my second value. It's the 8.674, and my x is the point. So that is what I will type in here. Try to make it where we can see both screens. So my actual equation and yours will be just a bit different, but remember that the back number goes first, 8.6. How many decimals did it want me to report? And make sure if there's a negative sign to report it. And 3, it only wants 3. So 8674, and then 0.801. Then it wants us to test whether the regression parameters are equal to 0 at a 0.01 level significance. Okay, so to do this step, what I've got to do is over here in data. Now, here's a note that if you do not have the data analysis over here in the analysis column, then you need to do the add-in. It's a free add-in, but Excel doesn't automatically load it up. So if you've never used data analysis before, you need to go right now, stop, and add that in. The directions to do that are in your text. And once you've got that installed, data analysis, and I'm going to do a regression model. And my Y is going to be my A column. And my X is going to be my B column. I have labels. It told me, I believe it told me, at a 0.01 significance. Okay, so it didn't tell me which confidence interval to use, but it's going to be 99 on other questions coming up. It's just going to be a 99%. I can tell it where I want my output to go. I can have it go into a whole new worksheet, but I like mine to come out here on the same worksheet. So I'm just going to tell it I want it to come to K4. And then I'm going to say, okay. I need to do A2 to A, no, A, how many are here? I can't just do A to A, apologize for that. So let me tell you how many are here. It goes to, oh good grief. Okay, 157. So A1 to A157, and then B1 to B157. And because I told it labels, I could do that. Otherwise, you would start with 2. I like to have the labels. So let me spread these out so I can see what they say. Okay. So it wants to know if it's significant at a 0.01. So I'm going to look at my p-value. And I'm going to say that my intercept has a p-value greater than 0.01, but my x does not. So I need to think when I'm answering that question. So BO is not equal to 0, but B1 is. So I need to choose the best option here. Then it wants to know how much of the variation in the sample values of total point earned does the model estimate explain. R squared is the value that tells us how much variance is explained. These are reported in percentages. Round your answer to 2 decimal places. So let me give it another decimal place, and it's 82.77%. So when it asks you for your percent of variation, it's always R squared. Mark spent 80 hours studying. Use the regression equation to determine what his grade would be. Okay, so remember, this was our equation. And now our studying is 80. So I can plug in the formula to say that 8.67, because we did that first one three decimals, 8674, and I didn't put my equal sign, plus .8014 times, we have our x now, it's 80, and our answer is 77.79 if it wants 2 decimals. Answer to the nearest whole number, so we would say he would score a 73. Question 2 is similar, so I'm going to keep this on the same video. This one's talking about cars, so I'm going to download the data file first. I won't make you. So I've opened the data file, and it says that Camry's one of the best-selling cars in North America. And so we're given information about 19 car sales, and it's showing us the mileage and the price that the car sold for. And it wants us to determine which of these scatter plots is most like ours. So we'll insert our scatter plot. Sorry. And then we'll see miles and price. And then you'll have to compare which one of yours. I think here's the trick on this one. Because miles is our independent variable, it should be at the bottom. So this is going to be my correct one. You got to watch. They tried to fool us on that. So I believe the story told me my independent variable miles as the independent variable. So that's going to be my conclusion. And then it wants us to answer some questions about how we interpret this chart. Then again, it wants us to do that regression equation, and it's so right click, add trend line, linear, let me see if it asks me for anything else. Let X represent miles. Okay. Linear. I want to display my equation. Okay. And my equation's tiny down here. So let me give it some oof. Let's make it a 14. Highlight it so we can see it. Okay. I don't think that made it a 14, did it? Oh, 12. Okay, that's still better. Okay, so I can plug in that my equation is 16.47. My x is negative, so I gotta make sure I put the negative there. Then it wants us to again look at the p-value. So to do that, I am going to data analysis, regression again. But because I've worked this problem before, I know that later down in the question I'm gonna need to look at some residuals. So when I run this, I'm gonna go ahead and put those in. So let me show you what this looks like. So I've got A1 to A20, B1 to B20. My output range, let's do it down here because I'm gonna have a whole lot now because I'm doing residuals. So let's say D20. I want residuals and I want residual plots for this question. Okay, and remember that my R squared is reported as a percent, probably with 2 decimals, and that these are probably going to be 4. Oh, and they were. Okay. So I'm looking at my p-value here to determine and they're both very small. When you have the E, whatever's behind it So this one says 06. That means there's 6 zeros in front of the number, and this one there's 4 in front of it. So they're pretty small numbers. So based on that, I have to answer these questions, and then how much of my variation is explained. And with 2 decimal points, we did that already. That's our R squared. And then it wants us to look at the best bargain. Okay, this is when we're going to use our residuals. In this case, I'm looking at the best bargain. So my residual is telling me what amount, what percentage below list price did this car sell for. So the bigger the negative number, the better, right? You always want to pay a whole lot less than what a car is listed for. So I'm going to sort these just so I don't overlook anything. Rather, I mean, you don't have to. You can look through this and determine which one's the best, but I don't want to miss any, so I always sort. I'm going to sort by residual, which was column F, it looks like. Smallest to largest. I have data labels, make sure that's checked. And so I can see car number 12 was the best. So I can put car number 12 in the data set, which has how many miles and sold for how much. Okay, well, car number 12. Now remember, these are residuals. Don't use these numbers. I need to go back up here and say car number 12. So that's 1, 2, 3, 4, and so forth. Make sure I get it right. Car number 12 is right here. And it had 28,000 miles and sold for 12,500. So I can fill that in here. Then it said, well, what was your second bargain? Well, if I come down here to my residuals, my second bargain is car number 4. So again, I will tell it car number 4 had 47,000 miles and sold for 11,500. Then it says, suppose that you're considering purchasing a previously owned Camry that has been driven for 80,000 miles. You're going to have a different value there. Use the estimated regression developed in Part B to predict the car's price. Well, this was my equation in Part B. And I know that my miles is 80. Remember, I'm reporting everything in thousands, so I need to take off the 3 zeros behind the 80. And now I just plug in the equation to say equals 16.47 plus negative 0.0588 times 80. And I will pretend that that decimal is a comma, and my car would sell for 11,766. That would be the answer for the predicted price. And then you're going to answer some questions about the Camry that you've determined from the equations that we've worked. And I will stop there and pick up with question 3 on the next video.